The situation we have here is Max got a 27 on the ACT, Sam got a 775 on the SAT Math. And the question is, which one is better? 27 on the ACT or 775 on the SAT Math? Can we say that 775 is better because it's bigger? Well, no, because these are two different tests that are graded on two different scales. So we can't just compare them directly. It's like asking who's better, Steph Curry or Shaun White. These are two different athletes playing two different sports. So it doesn't really make sense to compare them directly. How do we compare things that we can't compare directly? We're told at the top here the mean and standard deviation of both tests. If you know the mean and standard deviation, we can always make the empirical rule picture. So let's make the empirical rule picture for both situations. We're told that the mean for the ACT was 21 and the standard deviation was 3. Put the mean in the middle, and then use the standard deviation to go up 3 times and down 3 times. So 21 plus the standard deviation, which is 3, would be 21 plus 3 is 24, plus 3 again, 27 plus 3 one more time, 30. Going the other direction, 21 minus the standard deviation, 21 minus 3 is 18, minus 3 again, 15, minus 3 one last time, 12. And then we'll do the same thing for the SAT Math. The mean for the SAT Math was 514. That goes in the middle. Go up 3 times, so 514 plus the standard deviation, which was 87. So 514 plus 87, 601. Plus 87 again, 688. Plus 87 one last time, 775. Going the other direction, subtract 514 minus the standard deviation. So 514 minus 87, 427. Minus 87 again, so 427 minus 87, it's 340. Minus 87 one last time, 253. Now, notice, where is the 27 and where is the 75? Here's the 27, here's the 775. Notice, the 27 is 1 step, 2 steps. 2 steps above the middle. The 775 is 1, 2, 3 steps above. So, can we say that the 775 is better because it's 3 steps above versus the 27, which is only 2 steps above? Is that a valid way to compare? Turns out that yes, that is a valid way to compare how many steps above each score is. So let me elaborate on why that works. So this part, don't worry about if you don't follow. So the empirical rule says that for both pictures, the percentages are the same. So the percentages I'm talking about are between 1 up and 1 down is 68% of our data. Between 2 up, 2 down is 95%. Between 3 up, 3 down is 99.7%. And then the entire thing is 100%. Now, what I want to calculate here is what percent is to the left of this 27. And so I'm going to do this in 2 steps. First, I'm going to do middle to the left, and then middle to the 27. Middle to the left should be half of the 100%. Okay, so middle to the left is 50%. Middle to 2 steps above, so middle to 2 up, is half of the 95%. Okay, so 95 divided by 2 is 47.5%. Okay, and these two together, 50% plus 47.5% is 97.5%. So 97.5% is to the left of 27. What does that mean? That means that a score of 27 is better than 97.5% of all test takers. Okay, so Max, who got a score of 27, got a higher score than 97.5% of all test takers. Let's do the same thing for the 775. Okay, these percentages are the same, so I'm not going to write them again, but I do want to know what percent is to the left of 775. So I'm going to do it the same way, middle to the left first, and then middle to 775. Middle to the left, for the same reason that middle to the left here is 50%. Middle to the left is 50% also. Now middle to 3 above. So middle to 3 above should be half of the 99.7. So half of 99.7 is 49.85. And together, add these up, this is 99.85%. So Sam, who got the 775, his score was higher than 99.85% of all test takers. So it is valid to say that 775 is better than 27 because it's 3 above versus 27, which is only 2 above. And in particular, it's valid because 775 is better because it beats 99.85% of the people who took it, whereas 27 only beat 97.5% of the people who took the test. In other words, Sam beat more people than Max. Let's now take a look at example 1. So in example 1 now, Max got a 28 on the ACT, and Sam got a 710 on the ACT. Same question, which score is better? So now it's a little bit harder because notice that 28 is not one of the steps. 710 is not one of the steps. Okay, so our argument doesn't quite work now. But the question is, which one is farther to the right? The 28 or the 710? Well, the 28 is somewhere between 2 steps and 3 steps above. The 710, also somewhere between 2 steps and 3 steps above. So 28 and 710, we want to know which one is farther to the right, but they're kind of in similar places. So what do? We use what's called a z-score. Okay, so let me tell you what each part of this formula means. The x is our data. In this case, it's the scores. The mu, so this is the mu. We've seen this symbol before. It's a symbol for the mean. On the bottom, that's a sigma. We've seen that symbol before. That's the symbol for the standard deviation. So let me calculate the z-score for both situations, for the 28 and for the 710. For the ACT first. Okay, our x is the score, so that's 28, minus the mean for the ACT. What's the mean for the ACT? The mean for the ACT was 21. On the bottom, the standard deviation for the ACT. Standard deviation for the ACT was a 3. Okay, I'll need a calculator there, but let me set up the SAT one first. Okay, so for the SAT, our data or our score was 710 minus the mean for the SAT. The mean for the SAT was 514. And on the bottom, the standard deviation for the SAT math. Standard deviation, 87. All right, let's enter both of these into the calculator. For the ACT up top, 28 minus 21, on the bottom 3. Rounded to 3 decimal places, 2.333. For the SAT, up top, 710 minus 514. On the bottom, 87. Rounded to 3 decimal places, this is 2.253. So now, which score is better? 28 on ACT or 710 on the SAT? 2.333 versus 2.253. Which one's bigger? The 2.333. So the ACT score was better. So what does this 2.333 actually mean? Well, remember we said that the 28 was somewhere between 2 up and 3 up, right? This is saying that it's exactly 2.333 steps above the middle. In other words, it's exactly 2.333 standard deviations above the mean. The 710, we also said was somewhere between 2 up and 3 up. And what we calculated here is that it's exactly 2.253 steps above, or 2.353 standard deviations above the mean. So the z-score measures how many steps or how many standard deviations above and below the mean. So we can say that a 28 on the ACT is better than a 710 on the SAT because it's slightly more to the right than the 710 on the SAT picture. Example 2. Ashley took the SAT math test. Her score has a z-score of negative 1.28. What was Ashley's score on the SAT math test? So we're going to use the z-score formula, which was, let's recopy it, z equals x minus mu over sigma. Now, this example is different than example 1. In example 1, right, I gave you the SAT math score, which was 710, and we plugged it in for x. Subtracted the mean, divided by the standard deviation, and that gave us a z-score. In this example, I'm giving you a z-score. Right? I'm giving you a z-score of negative 1.28, and your job is to go backwards and find the SAT math score. So this negative 1.28 doesn't go in for x, it goes in for the z because it's a z-score. So we should put negative 1.28 in for the z. Okay, x is the SAT math score. That's what we're looking for. So I'll leave it as x minus the mean. That's the symbol for mean. The mean for the SAT math score was what? 514. And then on the bottom, that's the symbol for standard deviation. The standard deviation for the SAT math was 87. And now our job is to find x. Okay, so this is going to take a little bit of algebra. This is probably the only time in this class that you'll use algebra. So to get the x by itself, I need to get rid of the 514, and I need to get rid of the 87. So the first thing I'll do is get rid of the 87. Right now, it's on the bottom, so it's right now the 87 is dividing. To undo a division, you're going to multiply. So we're going to multiply both sides by 87. So on the left side, 87 times negative 1.28, we get negative 111.36. On the right side, dividing by 87 and then timesing by 87, that's going to cancel each other out. And we're left with x minus 514. We need to get rid of this minus 514. So that's a subtraction. So to undo a subtraction, you do the opposite, which is add. So we're going to add 514 to both sides. On the left side, negative 111.36 plus 514. 402.64. On the right side, subtracting 514, adding 514, that's going to cancel each other out. And we are left with just x, which is what we were looking for. So 402.64 was Ashley's SAT math score. All right, that's it for today. Have a great day. See you next time.